Each of the following angles is acute, right, obtuse, or straight. The angles are 127 degrees, 2 pi over 5, 179 degrees, and 90 degrees.
Going over test.
Well, most of us think better in degrees than we do radians, so let's do those three. This is more than 90, but less than 180, so it's obtuse. This is more than 90, but less than 180, it is obtuse. This is 90, so it is right. That just leaves that. And the dividing line is pi over 2, which is 5 pi over 10. And this is 4 pi over 10. So this is less than pi over 2. So it is acute. Number 2, find the complement and supplement of each of the following angles. So, for 73 degrees, the complement I spell complement right? I hope I did, yeah. Of 73 degrees, complement, their sum is 90. So this plus 17 degrees gives you 90. And the supplement your sum is 180, only 107 degrees. For the other angle, 3 pi over 11. So here their supplement is pi over 2. This is 6 pi over 22. And pi over 2 is 11 pi over 22, which means this is 5 pi over 22. Then we need to be correct. And supplement adds up to pi. So here's 3 11ths, so we need what? 8 more 11ths? 8 pi over 11 is the supplement. Okay. A few conversions. 53.24 degrees, and I want it expressed as degrees, minutes, and seconds. So, I'll take the 0.24 part, 0.24 times 60, that gives a 0.24 times 60 gives me 14.4. I'll put the 14 part there, and now the 0.4 really gave me 14.4 minutes. I'll take this, multiply that times 60. 0.4 times 60 is 24 seconds. I think the next one goes the other way. This is given 35 degrees, 42 minutes, 18 seconds. 35 degrees, 42 minutes, 18 seconds. It wants us to write as decimal degrees. 35 plus 42 over 60 plus 18 over 3600 degrees. Doing the arithmetic, 35.7. Oh, what's that? 0.5 degrees. I think that's right. Okay. And the last two on this problem says convert 75 degrees to radians. 75 degrees times pi over 180 degrees. Let's see, 15 goes to each of those. 15 goes 5 times into 75, and 12 times into 180. And going the other way, convert 5 pi over 18 into degrees, and it's 180 degrees per 5 radians. Pi divides, 18 goes to 180, 10 degrees times 5 times 10 is 50 degrees. Okay. Now we're down to definitions. And just mentioning, if you choose to retest on test 1, and you did not have the formula sheet for test 1. So for the retest, you may not use the formula sheet for test 1 if that's the one that you choose to retest. However, if you choose to retest 2 or retest 3, the formula sheet may be used. Okay, so we're given a right triangle ABC. Triangle ABC. With side A, little a, opposite angle A, side B, opposite angle B, and side C, opposite the right angle. That gives us what we need. Side C is opposite the right angle. And it doesn't matter what we label the other sides, A and B. It does matter where we label all the angles. So this is side A, opposite angle A, side B, opposite angle B. So we want to find the sine of angle A. Sine of angle A is its opposite over the hypotenuse, over C. That says the secant of B. The secant of B is its hypotenuse over its adjacent, C over A. And lastly, the cotangent of A. Cotangent of A is its adjacent over its opposite. The hypotenuse label remains the same, but the opposite and adjacent depend on which other angle you're looking at. Side A is opposite from side A is opposite of angle A, but side A is adjacent to angle B. And similarly, side B is adjacent to angle A, but side B is opposite angle B. Okay, number 5, find the exact values. So, sine of 240 degrees, I find it helpful to draw my little thing here. And these are angles that we should know. 30, 45, 60, 90, and some multiple of them. 240 is right here, which corresponds to 60. And we know that the sine of 60 is square root 3 over 2. But in the third quadrant, sine is negative. This is negative square root 3 over 2. Next angle says cosine of negative 7 pi over 6. Negative 7 pi over 6. Okay, minus pi over 6, minus 2 pi over 6, minus 3 pi over 6. Oh, I miscounted. No, I didn't. 1, 2, 3. Somewhere I've lost the plate. Oh. 1, 2, 3, 4, 5, 6, 7. This is negative 7 pi over 6, which corresponds to a positive 150 degrees, which corresponds to 30 degrees. And we say, what is the cosine of 30 degrees? And the cosine of 30 degrees is square root 3 over 2. And this is in the second quadrant. And the cosine of the second quadrant is negative. So this 2 is negative square root 3 over 2. And the last one on that batch is tangent of 120. Tangent of 120 degrees. Let's see, 120 degrees is 60, up there, 120 degrees. And the tangent of 120 degrees is the same as the tangent of 60 in magnitude, which makes it square root 3. But it's in the second quadrant, which makes it negative. Okay. And then it says, use a calculator to find the value of each of the following to the nearest 10,000. So, let's do that. Sine of 2.17, secant of 38.23 degrees, 38.23 degrees, and the cotangent of 7 pi over 18. So, this first one, no degree symbol there, so that's in radians. Sine 2.17. Somewhere here I have a thing that'll give me radians. 2.17 radians, and that ought to be 0.8258. Backwards is 0.8257849931, but to the nearest 10,000th, 0.8258. Next one is 1 divided by the cotangent, 1 divided by the cosine of 38.23 degrees, 38.23, close, and it tells me this is 1.2730, and if I run out, 1.273021014, again, to the closest 10,000th. And the last one, cotangent of 7 pi over 18. So that's 70 degrees. Because we converted 5 pi over 18 is 50 degrees, so that's 70 degrees. So, the tangent of 20 degrees is the same as the cotangent of 70 degrees. Kind of interesting. And this is 0.3640. 0.3639702343. Once again, to the nearest 10,000th makes that a 0. So, if you haven't already, you do need to remind yourself on how to use your calculator. Number 7. Given the angle U in standard position with point -940 on its terminal ray, find the exact value of each of the following. Okay. So, -9, positive 40, right there. -9, positive 40. Oh, yep. Because it's x and y. And doing the Pythagorean relationship, 1681 is 41. So we have measured, this is y, this is x, this is r, if you wish. And just before we write down numbers, sine of theta is y over r, cosine of theta is x over r, tangent of theta is y over x, cotangent of theta is x over y, secant of theta is r over x, and cosecant of theta is r over y.
Oh my gosh.
So, all we have to do is fill those in. -41, -9 over 41, 40 over -9, -9 over 40, -41 over 9, and 41 over 40. Number 8. A says, find the arc length of an angle of 4 pi over 17 with a radius of 51 centimeters. So wherever 4 pi over 17 is, radius of 51 centimeters, and arc length is r theta, where theta is measured in radians. In our case, that means 51 times 4 pi over 17. I picked nice numbers. 51 divided by 17 is 3. 3 times 4 is 12. 12 pi centimeters. Part B. Sector area of an angle of 54 degrees with a radius of 6 inches. Okay. Again, we have some angle, 54 degrees, radius is 6 inches. And we want the sector area. Sector area is 1/2 r squared theta, which in our case is 1/2 of 6 inches squared times, has to be in radians, and that is 3 pi over 10.
How'd you figure 3 pi over 10? Like,
Well-
how would you do that arithmetic?
18 goes that 3 times.
Okay,
18 goes 180 10 times.
okay,
So 18 degrees is pi over 10.
okay,
That's 3 pi over 10.
okay.
All right, so we'll work it out. 54 degrees times pi over 180 degrees. This reduces to 3 over 10 times pi.
Ah, there it is. Cool. Thank you.
And let's see. 36 divided by 2 is 18. 18 times 3 is 54. 54 over 10 reduces. 27 pi over 5 inches squared.
Yeah, don't forget that.
Okay. Often in application problems, so to speak, sometimes I just call them algebra land, because who really stands 2 meters from a wall and measures the angle up and the angle down? On the other hand, if you're a surveyor, back in the old days, you had to measure angles very precisely and solve those triangles. Now you just take your pole with GPS on it, and it'll record the location of the nearest centimeter after you stand there for a moment or two. Makes surveying a whole lot easier. But the software internally does what the old surveyors had to do manually. Okay. And if you think about who is it? Mercator? Yeah. Mercator projection. Mercator was one of the French scientists who measured near along what would be the Greenwich Meridian from Barcelona, Spain to London, England, by measuring angles carefully and the dip that you got because of distance, and figured out how big a meter should be, because they'd already decided a meter would be 1/10 millionth of the distance from the North Pole to the equator along the prime meridian. And that was its original definition, and that definition stood for a long time. Now it's been changed again, but for many years it was
the scratch mark between our two scratch marks on a iridium rod kept at a constant temperature at the Bureau of Weights and Measures in Paris, France, and with several duplicates around the world. But you know, things being what they are, they have recently decided to recalibrate everything. It doesn't make a hill of beans difference to our everyday measurements, but you know, if you're measuring it either in the nanometers or the light years, maybe it makes a little bit of difference. Okay, so here we are. 0.2 meters from the wall. There's the wall. Here's your eye. I can get fancy and have eyelashes. Eyeball. 2 meters. And part of the bottom of the painting is 12 degrees below your eye level. 12 degrees. And the top of the painting is 31 degrees above your eye level. I'm going to make the conversion. This is 200 centimeters. To the nearest centimeter, how tall is the painting? So here we go. It doesn't matter. We didn't ask how high is it from the floor because, you know, if a taller person was here, then those angles would change. But the result would still be the same. Okay. So this side is 200 times the tangent of 12 degrees, and this side is 200 times the tangent of 31 degrees. And clearly, to get the right answer here, we're going to add 200 times tangent of 12 degrees plus the tangent of 31 degrees, rounded to the nearest centimeter. So, calculator tells me 200 times parenthesis tan 12, close, plus tan 31, close, close, equals 162.6834361 centimeters. So my answer is 163 centimeters.
I got a question. Can you not just add the 31 and 12 and just do it
No.
that? Okay.
Let me ask you a simple question. What's the tangent of 45? 1.
Oh, okay.
What's the tangent of 45 plus the tangent of 45? 2.
2.
What is the tangent of 90? Undefined. Really big.
Okay.
So 1 plus 1 does not equal forever.
Okay, I just want to ask
So
that.
yeah, you cannot,
Don't make the mistake.
yeah, do not make that mistake.
Okay, I was just curious.
Number 10, find a Pythagorean triple containing 11. Okay, the easiest Pythagorean triples to find is if one of the numbers, given numbers, is odd. Because then we can come up with the difference 1 triple.
Oh, my favorite.
Basically divide that in 2, round up and round down. And that would be a Pythagorean triple containing 11.
I spent like 15 minutes with a calculator kind of
So
figuring this
you
out.
just
You do what?
square-
Go one more time. Like step by step.
Square the odd number
Okay.
and then divide by 2, rounding up and rounding down. Divided by 2, we get 60 and a half.
So are you gonna give us an odd number on the test?
Yes.
No.
You give us an even, I'm probably gonna cry.
There you go.
You'll just see tears just on my face.
I believe it. We'll do that.
That's funny.
This square is 1, 2, 3, 4, 5, 6, 7, 8, 9, 8, 7, 6, 4, 3, 2, 1. So half is 6, 1, 7, 2, 8, 3,
9, 4, 9, 3, 8, 2,
Show off.
7, 1, 6, 0.5. So the other two numbers are 6, 1, 7, 2, 8, 3, 9, 4, 9, 3, 8, 2, 7, 1. Find the linear velocity
11.
of rim of a wheel in meters per second if a wheel has a radius of 36 centimeters, has an angular velocity of 6,000 RPM. Basically, linear velocity is equal to angular velocity times the radius with compatible units. So our angular velocity was given in RPM, but must be in radians per something. So we have 6,000 revolutions per minute
RPM.
times 2 pi radians per revolution times 1 minute in 60 seconds times 0.36 meters per radian. That's R. Okay. So we have it. 60 and 6,000 is 100. Times that is 36. Times that is 72. 72 pi meters per second. If I did the arithmetic correctly. Someone might do the arithmetic. See if that came out. Okay, given the unit circle, x squared plus pi squared equals 1, and angle theta in standard position, obtaining the point negative 12 over 37 and negative 35 over 37. Now this is very similar to number 7, which was similar to one of the others, I don't know. So the point given is negative 12 over 37, comma negative 35 over 37, which, by the way, 12, 35, 37 is a difference 2 triple. You don't need to know that to work the problem, but if we have a unit circle, some angle in standard position, coordinates x, y, then sine of theta is y, cosine of theta is x, the tangent of theta is y over x, the cotangent of theta is x over y, the secant of theta is 1 over x, and the cosecant of theta is 1 over y. So in our case, with these values, this is negative 35 over 37, this is negative 12 over 37, this is 35 twelfths, this is 12 35ths, this is negative 37 over 12, and this is negative 37 over 35. Which now brings us to test 2.